Hello and welcome to Microchips. In this episode we will be building the esp8266 LED controller kit to control ws2811 or similar LEDs. Let's take a look at the parts needed for the kit. A ws D1 Mini, some capacitors, a SN74AHCT125D level shifter and socket, a 10K and 220 ohm resistor, two PCB connectors, a 3.3 volt regulator and heatsink kit. Now let's start the build. I'm using blue tack to help hold the board and its components while soldering. First, let's assemble the ws D1 Mini. This can also be done on breadboard. Place the pin headers into the board and place the ws onto the pin headers. Once seated correctly, solder the end pins first. Check the pins are seated correctly on the ws. Once happy, solder the rest of the pins, making sure not to short circuit any of the pins together. Once seated correctly, solder the end pins first, then check the pins are seated correctly. Once happy, solder the rest of the pins. Be careful not to short any other connections together. When soldered, the ws can be removed and put aside for later. Now to assemble the regulator and heatsink. Place the insulator on the heatsink aligning with the hole in the rear of the metal heatsink. Place the plastic insulator on the screw. Place the regulator on the heatsink. Place the screw into the hole and tighten. Take the two PCB connectors and place into the holes. Use a small piece of blue tack to hold them into position. Turn over the board and solder into place, noting that the negative terminals require more heat because of the copper ground plane. Next we place the IC socket. Place onto the board, noting the orientation of the socket, and hold down with blue tack. Solder the end pins first. Check the socket is seated correctly and solder the remaining pins. Next we place the resistors. R1 is a 10k ohm and R2 is a 220 ohm. Bend the legs of the resistor and place into the board and hold with blue tack. Solder the resistors into place and snip the excess wire with some cutters. Next we mount the capacitors. They are marked 104 for 100 nanofarad. Place them into the board and hold with blue tack. Turn over and solder and cut the excess wire. As they are ceramic disc capacitors, it is not important which way they are placed on the board. Next we fit the electrolytic capacitors. It is important to fit them correct polarity, which is marked on the capacitor and on the board. Place the 10 microfarad into the board and hold with blue tack. Be careful when soldering this, as the connections are very small. Next we place the 1000 microfarad capacitor, noting again the polarity, and holding with blue tack, turn over and solder into place. And remove the excess wire when finished. Now it's time to fit the regulator into place on the board. Place it on the board as shown and hold with blue tack. Turn over and solder, noting that one of the connections will take more heat to solder. Once soldered into place, remove the excess wire with cutters. Let's check the voltages on the board work properly before we fit the WMOS and level shifter IC. Connect a 5V power supply to the plus and minus on the board, and with a multimeter set to DC, measure the point shown. You should see 5 volts and 3.3 volts. If these are present, we are good to continue. If not, check your soldering for bad or short circuit connections. Here we have the 5V supply, and here we have the 5V for the level shifter, and here is the 3.3 volts from the linear regulator. All the voltages look good, so we can proceed with the rest of the installation. We take the WeMOS D1 and place the extension pins onto the WeMOS and place it onto the board as shown and secure it in place with some blue tack. Turn the board over and solder the end pins first. Check the extension pins are seated correctly and then solder the remaining pins. Once soldered, check for short circuits, remove the blue tack, and now you can remove the WeMOS from the board and place it back again. This is especially handy for programming. Lastly, we're going to fit the level shifter IC into the socket. The pins on the level shifter IC will need bending slightly so it fits into the socket correctly. Place the level shifter IC on a flat surface and bend the pins ever so slightly, noting the orientation of the IC and noting the orientation of the silkscreen on the board. Place the level shifter IC into the socket as shown and press firmly. And there the board is complete. That's the soldering completed. Now let's test the unit. Connect the data line of the LEDs to the D on the board. And connect the plus and minus to a 5-volt supply. And also connect a supply to the LEDs. If all is good, when we apply power, the test sequence that has been pre-programmed into the WeMOS should run, and you should see various animations on your LEDs. Please note this animation script, the test script, has been set for 100 LEDs. A full schematic and parts list can be found in the links below, as well as the Arduino test script for the WeMOS D1. And that is the kit complete. There is one other optional extra that can be fitted, an OLED display or any other display that uses SDA and SCL for communication. There are libraries available for all types of displays. I hope you found this video useful. Please like, thumbs up and subscribe. Links are below for the kit and pre-built tested boards. Thanks for watching and goodbye.